Okay, so today we're going to learn how to graph in our TI Inspire some piecewise functions. So let's look at this one. So this has 3 pieces to it. So I'm going to click the key next to number 9. It's the template key. And I'm going to go to, let's see, I believe it's that one. So it has 3. It's actually customizable. It says 3 is the default. So I'm going to have 3 pieces to my function. So the first one was x minus 2. Oops, x minus 2. And the domain was x less than or equal to. If you hit control equals, you can choose less than or equal to, -3. Cursor down, that'd be -2 for that function, and -3 less than x less than or equal to would be control equals 2, and square root of x then x greater than 2. And it's really cool. It graphs the function really nicely. You can see the 3 different pieces there. It's all one function on the calculator. If you hit menu, like if you're not sure, menu 5.1, for example, at -3, it looks like. So if you go -3 and press enter, it'll jump and show you, oh yeah, that point is on that part of the graph. That's a closed circle there, which means it would have to be an open circle right up there. If you're not sure about 2 in trace mode, you can type in 2 and press enter. You can see it's a closed circle there. Up there would be an open circle to start with when x is 2 up there. And so it's just a nice graph of the function there, just showing a couple of those points. If you're having trouble, see if they're open or closed circles. So it's pretty quickly, pretty easy to graph in TI Inspire, even with piecewise functions. So a function is a bunch of ordered pairs. It's a type of relation that every element of the domain is paired with only one element in the range. And so the test for this is called a vertical line test, right? So vertical line test. So let's look at this. So here, doing a vertical line test. If you kind of pass an imaginary vertical line test over a function, you can see that right now it only hits at one point at a time. That vertical line is just hitting that function just at one point, which is what you want for a function. If I move this vertical line, so it looks like it hits here, right there, and right there. The x values are the same, 2.69. The y values are different. So this clearly is not a function. It does not pass the vertical line test. If you draw an imaginary vertical line, you don't need any fancy calculator stuff here. You just look at it. You go, those 2 lines are vertical from each other. That is definitely not a function. Here, you can probably just tell from looking, that's definitely not a function. It doesn't pass the vertical line test. So what you are looking for, again, are things like this, where it does pass the vertical line test because it only crosses at one point at a time. Okay, so one way is to look at a graph. That's actually a pretty easy way to do the vertical line test. It's a little tougher when they ask it, is it a function? This is basically a way of saying, is this a function or not? And so to test it, we're going to solve for, so does y define as a function of x? So I'm going to solve for y. So I'm going to take that, move that by subtracting it. You get y equals 9 minus x squared. That is, yes, a function. I solved it for y, and I got one thing that I can graph in my calculator, 9 minus x squared. It's just something you can graph in your calculator. The graph of that is probably going to look something like this, I believe. Crosses the 0, 9 up there. It's a parabola, but it definitely passes the vertical line test. Okay, so it's hard to tell. I mean, a lot of functions you solve for y, it's just one thing, but watch what happens when you try to solve this one for y. So something interesting here happens. So you get y squared equals 4 minus x squared. Everything looks fine right now. But to solve for y, I'm going to take the square root of both sides. Don't forget plus or minus, so I get y equals plus or minus, that doesn't really simplify, 4 minus x squared. Notice the key thing there is this is plus or minus. Those are two different functions. So this is no, not a function because it's two different functions. In fact, if you graphed it, it would have a radius 2. It's a circle with a radius 2, something like that. It doesn't pass a vertical line test. It would cross twice. If you drew some generic vertical line, it's going to cross that function in two different spots when it crosses through that function. So it is not a function. You solve it for y. If it's more than one thing, it's not a function. So to solve this for y, subtract 2. So I get x minus 2 equals absolute value of y. Because I'm solving for y, I want to take the positive negative case. So y is equal to x minus 2. That's one case. Or negative y equals x minus 2. Or y equals negative x plus 2. That's a negative x there. So I get two different functions when I solve. So this is no, not a function. Because again, I got two different functions there. Here it takes one step. You're going to take the cube root of both sides. Here I put plus or minus up there because I took the square root of both sides. You take the cube root of both sides, but you don't have to put plus or minus. It's an odd root. So you just get y. That's one thing. You can type that in your calculator. That is yes, a function. So only when you get plus or minus or two different equations or something will that work. So here we've got a piecewise function. It's in three pieces. We're read it as one function because I call it f. So f of x equals, and I'm going to go ahead and put the template for it. It's going to be something, comma, something, something, comma, its domain, something, comma, its domain. All right, so let's just do this in pieces here. So this first one is going to be this one. I'm going to do this in red. So it's going to be, sometimes it helps to do the domain first. I might try that. So this is going to be x is less than or equal to negative 2. The slope looks to be up 1 over 2. So negative 1/2 x. The y-intercept, if it kept going, looks like it would cross there at 3, so plus 3. Let's do this one in green. Okay, so this one, let's do the domain first. It goes from negative 2 for x, less than x, less than 3. And it looks like the function would be just a horizontal line, so f of x, or which is the same thing as y equals positive 2. And this one I'm going to do kind of in that purplish, so this would be x greater than or equal to 3. And the slope looks to be 1, so 1x or x. The y-intercept looks to be negative 3, so minus 3. And I've got my piecewise function, right? So just a couple of some linear lines, one's horizontal with a slope of 0, and you got it. This one's a little tougher. So I don't know if you recognize these points here. I do, 0, 0, 1, 1, 2, 4, negative 1, 1 right there. So that looks like a very familiar function. So f of x equals, I know I have two pieces here, the function, comma, its domain. The domain of the this one I've been putting points on would be from negative 1 less than x less than, well, actually, I don't know why I'm saying it that way. It's not really sandwiched in between two values, right? So x is greater than negative 1 would be the domain. Looks like it starts at negative 1, but not including that point. And it looks to be just the basic parabola there at just x squared, just your parent graph that hopefully you kind of know by now. This one I'm going to do in blue, so this is a domain of x is less than or equal to negative 1, or from negative infinity to negative 1. Looks like the slope is 2, so 2x, it's positive. The y-intercept would be 2 if it kept going, so plus 2. And you've got your piecewise function working backwards. That's the lesson for today.